As you can kind of see here, this is how lightning works. There are two possible ways in which lightning can strike the ground. It's basically always going to be a flow from the changes in charge. So as you can see, the upper atmosphere always has high positive. The lower is typically negative. You can have inner cloud lightning, which would be the positive upper part to the lower negative part. You could also have from the high to the low in this case. During the summertime, a lot of heat creates, and that's where you get mostly inner cloud lightning exchange. It does travel rather fast, going up to 60,000 miles. When you actually look at the connections that are made, it originates up at the cloud itself, and then it builds upon itself. But before it occurs, you'll notice here, lightning actually comes from the bottom of the ground as well. So some people said, I remember growing up, I always heard that urban legend that lightning came from the ground. It doesn't. It starts at the cloud, but it does form the cloud, and then it connects. And when that occurs, that connection, then there's a return stroke, which is going back into to the cloud itself. And that's kind of the more powerful. The temperature that it can occur with that is about 55,000 degrees Celsius. I was reading something online. Not as many people actually die from tornadoes as we initially think. I mean, from or lightning. A couple things that straight line winds can be as damaging as tornadoes. When we have the straight line winds, they can be in front of the thunderstorm line, and they can cause pretty ferocious winds that are up to the same as hurricane gusts, and they can last for 10 to 15 minutes. These are what actually hit Omaha a couple years ago, causing some major problems. And one of the things that usually happen is in the summer, you get a lot of hot, humid air that kind of causes this. These frontline winds will actually kind of create a wraparound effect on the storm. So instead of having this movement, air just moves straight up, it kind of actually moves around and it wraps and creates in the front these sidewind patterns. And these winds here are the ones that are going to straight line winds that can cause pretty substantial damage, leading ahead of the actual thunderstorm itself. Typically, it has to be pretty warm out, very massive winds for this to occur. Tornadoes are basically just rapidly turning columns of air. Okay, they have to happen in a thunderstorm, so all those conditions for a thunderstorm to be met must actually happen as well. Interesting fact, 70% of all Earth's tornadoes actually happen in the Great Plains of the United States. We call that Tornado Alley. It stretches from Texas up to Nebraska and then east all the way into Alabama. Okay. So what actually makes a tornado? You need the perfect storm. Now this is obviously an important note. The entire thing is red. You need 3 air masses. Okay. What are the 3 air masses you need? You need, number 1, warm, humid air that is you need warm, humid air that comes from the Gulf of Mexico. You need cold, dry air that typically comes from either the base of Canada, so like sitting over Alberta and all those areas, or the Rocky Mountains. Okay, and then when that occurs, you have the combination of these 3. You get this shearing occurs. The last thing that you need to have occur is that high altitude jet stream to kind of spin the reaction. So you can kind of actually see this here. Here's the jet stream up top in the upper parts of the thunderstorm. You also will have, in the case here, the combination, the mixture of that cold, dry air and the warm, humid air, creating this huge updraft. The updraft, along with that, kind of creates a spinning effect. Rising Gulf air is going to be spun and in creating like a corkscrew effect. Notice the rising air is on the leading end, cold air is on the descending end or the trail side. Okay. The fast winds are on that back end here. Typically, it's heavy rains before a tornado, and after the rains kind of go up, the rain will actually stop because this is that cold air that's moving down. The downward moving air, the tornado's spinning in here. The downward moving air is what actually kind of creates the push down and eventually leading the tornado to touch down. Okay, so this both effect, rain pushes it up, this corkscrew effect's occurring up in the clouds, and then the cold air, because there's a huge difference in temperature, kind of drops that tornado down to the ground. Okay, and you can kind of see it here in the cloud itself. You get this the wind effect here that's creating the jet stream. It's that cold air that's occurring. This storm would be moving in this direction here. Okay, the back end of the storm is where the tornado will actually touch down. Okay, and the cool, dry air on the trail the tornado comes from. Typically, you look towards the back end. The downward moving air will enter this part and causes it to go down. So what they need is cold, dry, and high pressure air will blow up from the plains and it will collide with that warm, moist air, which is low pressure from the south. The warm air will spin upwards, explosively forming that tornado as it goes up and then comes down. You can see on the storm, here's the two pressure systems. Where those collide, that's where the tornado is going to occur. Where do they actually occur? Once again, you can kind of look at Tornado Alley. The highest percentages per year. We're kind of on the tip of it. The most of it's down in that Texas, Oklahoma area is the highest percentage. Notice you don't have a lot in Florida. You don't have a lot in the West Coast or the East Coast. They can have some per year, but it's pretty rare. Why? You don't have the three air masses. You don't have the warm, moist air coming up here, and either you need a combination of cold air coming from the Rockies or from Canada kind of hanging up in this area, along with that jet stream. All three of those areas don't have that, therefore that's kind of the key area. During different years and different cycles, this little arrow can actually move north or south just depending on the current climate that the North America is in. This is going to be important on the test. You always hear the F1, F2 kind of scale. There's two things. Number one, when you hear about these are always based on kind of the new enhanced Fujita scale is based on not just the wind speeds, but also the damage, which are both take into account. So a lot of times these will only be figured out after the tornado has occurred. You can't tell it during. You got to see the damage that occurred. You can see an EF0 all the way to an EF5. Notice it doesn't talk too much about even the size of the tornado. They can differ in there. It's about the wind speed and the tornado damage. Okay. What are the three causes that can cause the damage? Number one is high speeds. Okay, causing a lot of projectiles. Projectiles are actually the more common killer in these conditions. People are outside and they don't even see they see the tornado. They're away from the funnel, but the winds outside of it will whip up a 2x4 or whatever. You heard that a lot in our talks with Mr. Nats and Mr. Monzu. Okay, air pressure inside dramatically goes up. And what it'll actually do is kind of cause the roof to pop off and the walls to bounce out. So it's not necessarily that when a house blows over that the tornado actually itself pushes it over. It literally pops the top of the house off because of the change in pressure. That high pressure situation in the house is what can cause doors to become sealed shut, preventing people from moving in the tornado. Tornadoes have been on the decline for a number of deaths. The reason is better warning system. Okay. Less people live in mobile homes, and people know how to prepare for them. For example, back in the 70s, it wasn't uncommon for people to buy in Nebraska mobile homes. Now, it's a lot rarer to see that because people would rather buy smaller starter homes with a basement than not have those. Basements in Nebraska, you ever go to a house that doesn't have a basement, it's extremely rare. And if they do, they almost always have some type of cellar or something to go in case of a storm. Tornadoes in cities, they do kind of pop up around cities. The reason is because the cities, the concrete in the city will actually absorb more heat, and in doing so, the air pressure kind of goes up, or the temperature goes up. That warm air over the city can kind of create thunderstorms. You'll see in the summer, I want you to pay attention to this, you'll see a lot of storms kind of popping up in July just outside of Omaha, okay? The warm air rises over Omaha, hits the Missouri River, that gets thunderstorms. This can also include and create different tornadoes, and you can kind of see the list here. So cities can have an impact on tornadoes. What I want to do now is just go over some things that might help you on the studying for the test, so hopefully you stayed through this video and you're going to watch some of these. So Some key terms that you'll know in the very first few questions that have to define albedo, dew point, front are all things that you'll need to know. We talked a little bit about the storm of the century. What was it? What did it cause? Give me some details about it. We talked about two major jet streams that there are in both the North and South America. What are those two jet streams called? So you have like the polar jet stream up north and the subtropic jet stream are the two types that you'll need to know. How fast are the winds going in the difference? So about in the polar jet stream, there's a build of about 600 miles. How fast does the speed go of that jet stream as it travels around our planet? Those are questions that are directly from your notes that I said would be important to know or to figure out. And once again, the cause of the storm of the century, we've talked about that. That'd be something that would be a question test. Which direction? We talked about the northern, southern hemisphere, how the storms move. You'll want to know that. Which type of front is most likely to produce a thunderhead in massive storms? Would it be a cold front moving in or a warm front moving in? Which one's going to create the actual thunderhead and more chance for massive severe weather? We talked about how much death severe weather cause per year when it comes to natural disasters. That'd be a question I could possibly ask. It was in yellow or red. It was about 75% of yearly deaths are caused by severe weather. A lot more than when you look at more than earthquakes, volcanoes, and movements combined. When water vapor condenses, it actually is going to release latent heat. We talked about that as well. So something that you want to make sure to remember, all things that are important. What direction do, in the northern hemisphere, do cyclones travel? So we're talking about mid-latitude cyclones. What direction do they move? What's the biggest problem with thunderstorms? Why do they cause havoc? What's the issues that they have? And which state in the United States has the most days of storms, thunderstorms specifically? Is it Texas, Florida, Illinois, Indiana, or Ohio? We talked about that. What actually had the most? Another question could be is how much money did severe weather cost the United States between 1980 to 2005? That could be a question on the test, maybe in a multiple choice format. What is and this was from our video today, a widespread powerful storm with straight line winds? What do we call that? Starts with a D. I might give you a map of the country and expect you to tell me where the highest wind potentials are, where rainstorms are expected. We talked about tornadoes and what causes them and where they occur, and what percentage of the tornadoes on our planet occur in the mid-plains. I gave you a very specific number on that video today of how many percent of the tornadoes worldwide occur right here in the area that we live. Uh, 75%, by the way, if you're wondering, occur in the mid-plains of the United States. And there's some questions about energy and things like that, like all of the Earth is heated up equally. If that was the case, we'd all be the same. If not, the equator gets warmed a lot more. Does cool air hold more water, or does warm air? That'd be a good question to ask on the test. And I'll probably have a couple short answer questions, like compare and contrast and give examples of weather versus climate. Compare and contrast and give examples of weather versus climate. Another possible short answer question I could ask is, what is a mid-latitude cyclone and what causes it? On a large, medium, and local scale, what does a mid-latitude cyclone cause or generate? And then what makes a tornado? And why do the Great Plains an ideal place for tornado formation? What do storms that produce tornadoes form? Why do storms produce tornadoes over large metropolitan areas? And what bodies of water? I'll repeat those. this last one. But those would be three possible short answer questions. What makes a tornado? Why is the Great Plains an ideal place for tornado formation? And why do storms that produce tornadoes form over large metropolitan areas? Those are some things that hypothetically could be on the test, so hopefully you watch this, and best of luck.